So we can also go through, let's say, this is a cooling system for I think it's a ramjet, basically what's it would be called? Just a big radiator. This goes on the inside of it's not a ramjet. I can't remember what it's kind of turbojet, something like that. But fantastic jet, and we were basically told to optimize it. This is, I don't know, a couple thousand individual parts that have all been welded together, maybe a couple hundred. I'm not exact, I can't count all of those pipes, but say that's 100 pipes going down times 50 different possible, not 50 different possible, let's say times 25 different, basically, one of those sheets. That's a lot of different parts for someone to manually assemble together. So what we did was like, what would you do if you could print it? So then we made this, which was slightly easier to design than the original part. So I mean, that was probably pretty easy to design. This was just as hard, I mean, just as easy to design, but we're done now. There was no like, how do I assemble it? How do I what's the workflow in assembling this part? It's literally just print it out and you're done. And so the workflow for this one was pretty similar to the last one in that it was basically just let me delete these guys. Basically made a cylinder, got a curve, and of course this curve would be more engineered than what I just made there, but like that. And then let's also make a vertical pipe. And so a lot of times I'll just model these things as one object, or like in this case it's a symmetrical part that I can just array. Number of items 25. Let me copy that to the end, select all of these pipes. Pipe 2, nope, too big. .5, still too big. 0.1. So now we've got a bunch of, that's tiny. 0.3. I don't know why it's not letting me do that. Pipe, select all of it. 0.4. We've got all of these pipes in here. Basically a radiator. Like, that's pretty simple. If I just array that whole structure around this curve by 25 times, I've got a decent radiator going on here. And then I could take it into ZBrush. That's weird. Let me go back. Pipe. Cap round. Array. 25. Pipe. 1. So very quickly, I've got that radiator in there. Nothing's really Boolean together. Nothing really works super well. But I could take this into, I could either Boolean union this all together, and that would be quite a Boolean union command. Or I could literally just export it to ZBrush again. And this will be one where I go from Rhino to ZBrush to Magix. So we're going to call that number 5. See, right? It's taking a good period of time to Boolean, or even just export. And then you can see this getting that issue, like the Boolean issue and the other sort of NURBS modeling issues should be pretty cumbersome when you're trying to make a really complex part. Not to say really complex parts are bad, but like if you would really like to take advantage of a lot of these things, like a lot of the spinal fusion cages have lattice structures on the inside of them that could contain thousands of individual lattice pieces or individual little struts. And so trying to work with that as a mesh or as a NURBS object would just kill your computer. Oh, so if I Z plug in 3D print exporter, STL import. I think I called that. What did I call that? Oh, I never clicked the final button. There we go. STL import 5, I think I called it. Still thinking. Still, yeah. So like it takes a good time when you want to make stuff this heavy, just to do simple steps. So Z plugin STL import 5. Takes leaving some time to load in because it'll be a very heavy file. But once I move it into ZBrush and retopologize it, it becomes much lighter and easier to work with again. And so like literally it's loading. Let's see. We can even maybe open it in Magix and skip a step. So if I open this in Magix file, no. And so Magix basically just takes your file and immediately turns it into a mesh upon import. Yeah, that's a heavy file. I should maybe reduce that that count down. Yeah, it's 1 gig. That's why. So very quickly in Rhino, I made a 1 gig file, and that's not even half of that radiator. That radiator, or that heat exchanger is far more complicated than this. And that was almost in no time. Yeah, Magix is struggling. And so let's reduce this number a little bit. Array this curve along here. Like that. Did it open it? No, still no. So that's such a lighter file. Let's see if this can open it. Let's pipe this external pipe too, just because. Export. Heat exchanger 1. Once it's done exporting, even this takes a good while to export. Click OK. Import this. All right. So we've got this heat exchanger in here. Gonna zoom in so I can see what I'm doing. And then basically just really quickly, the same workflow as earlier. Weld the points and then retopologize the object so I can make it something I can work with. Actually, welding points may not have worked. Wait for program to respond. It's because this is thinking so much. But so a little like working between different mesh modeling programs and different NURBS modeling programs, even though it's not super fast right here in front of you, does save a lot of time, particularly for specific objects that, like with this one, for instance, all of those pipes I just made are solid. Like I didn't hollow them. They don't have thickness. They're all just, oh no, not that. Heat exchanger 1. Gonna let that import for a minute. But like, oh, there we go. Edit. Zoom in. Geometry. Dynamesh.